Polynomial stems from the Greek many terms. So poly means many, and nomial means names, or in this case, terms. A polynomial can have three different aspects. So in the polynomial 5x squared minus 12x plus 7, there are constants like 5, negative 12, and 7. There are variables, for in this case x, but you can use any variable. And there are exponents, in this case 2. So this is the degree of the polynomial. So this is a second degree polynomial. Factoring is finding out which expressions multiply together to get a polynomial. So factoring is the opposite of expanding. So another example is 4x squared minus 9. So you guys can see that there's no common factors. So this is a special case called the difference of squares. So difference of squares is this. It's a squared minus b squared equals a minus b multiplied by a plus b. So that would be 2x minus 3 and 2x plus 3. So that's the factored form right there. It's the factored form of 4x squared minus 9. So to factor this, we can use the difference of squares, which would be w squared minus 4, w squared plus 4. And so you might think that this is a fully factored form, but you would be wrong because this is also a difference of squares. So w minus 2, w plus 2, and w squared plus 4. So this is the fully factored form of w squared minus 16. So a quadratic is ax squared plus bx plus c. A, b, and c can have any value, except a cannot equal 0. The way that you would factor a quadratic would be finding out what multiplies to ac and adds up to b. 2x squared plus 7x plus 3. So we can find out what multiplies to 6 and adds to 7, which is pretty simple. It's 6 and 1. Separate out the middle term into 6x and 1. So we get 2x squared plus 6x plus 1x plus 3. And these are obviously equivalent. And then you can factor the very first two and last two individually. So you can do these two only have x in common. So then you can get 2x plus 1 as a factor of that. And then these have 3 in common plus 3, which is 2x plus 1. So you'll get as your final answer 2x plus 1 multiplied by x plus 3. When a times c are both really large, it can be difficult to find factors. So you can use the quadratic formula. So that's the quadratic formula. Factoring finds the roots of a function, and the quadratic formula also finds the roots of the function. The roots of a function are when the function equals 0. The next example is going to be finding the factors of 8y squared minus 2y minus 15. B in this case is negative 2. So AC, when b is negative 2, you can see the obvious factors are negative 12 and 10. 8y squared minus 12y plus 10y minus 15. So that is the factored form of this. So this would be equal to 0 when x equals 3 halves. And this would be equal to 0 when x equals negative 5 fourths. The way that you would factor a cubic function is your first strategy would be to factor in pairs. So this is a pretty easy example because you can just do basically what we were doing earlier. And then from there you could do 4x squared minus 9, x minus 1. So that is the fully factored form of this expression. That is your first strategy. So your third strategy is the difference of cubes. So that is xy squared cubed minus 4 cubed. So using that, you can use this. So that is the fully factored form, because this cannot be factored any further, of this. So the next example is going to be 4x squared over 9 plus 2. So that this is also happens to be the equation for a section of the IKEA logo, because this has no x-intercepts, so it can't be factored. So first thing, we're going to find the y-intercept, which is 2. And then from there, you can plug in points. So I'm going to plug in something that will make this easier to do. So 3, 6. And then the negative version of that is right here. Perfect. Thank you, IKEA logo. The graphing cubic is the next one. You're going to need to use rational roots theorem. So first, in doing rational roots theorem, you would arrange the polynomial in descending order, so like this, so descending order. And then second, you would do the factors of the constant and the leading coefficient. So plus or minus the factors of the constant factors over plus or minus the factors of the coefficient. And then you can use a box method or synthetic division to find out if it's true. The factors of this are plus or minus 2 over plus or minus 1. So this would be either 2 or negative 2. And so I am going to use the box method. So negative x minus 2 x squared plus 2x plus 1. You can factor this. So the way that you can graph this one is by seeing the multiplicity, first of all. So a multiplicity of 1 means it crosses through. We have a multiplicity of 2, which means it bounces off of that point. And we had an example earlier, this one, where this had a multiplicity of 2, and as you can see, that is a vertex. And the vertex is always like the lowest point, it bounces off that point. And a multiplicity of 3 is an inflection. So let's graph this function. So we know there's going to be a root of x plus 2 and negative 1. Bounce off, and then travel through like that. And that is the graph of this equation. Yeah. So that pretty much covers most of the polynomials. Quartic functions are difficult to factor, and they don't have like a set structured rules. You can use rational roots theorem on any degree polynomial. And that's pretty much the only secure way to factor a quartic function. Graphing a quartic function is similar to graphing a cubic function. Just find all of the factors, and you have enough information using the multiplicity to draw a graph. So yeah, that's pretty much how to factor, graph, and just use all polynomials. Goodbye.